Kia ora, Year 12 and 13. Welcome to this short video in which I go through the proof of the first of the compound angle formulae. Now I'm going to follow the derivation in delta. It's in the appendix, it's on page 406. You may wish just to go straight there and do it yourselves, or you can watch this video. The reason that we need to think about having compound angle formulae is because we can't just say that the cosine of A minus B is equal to cos of A minus the cosine of B. And that's quite common in maths. Often when we have a function, it's not going to be linear. So if our function is 1 over a number, if we have f of 2, we get 1/2. F of 3 is 1 over 3, or 1/3. Now if we look at f of 5, we get 1/5. And that's definitely not the same. Oh, pen's gone wandering, which is not the same as 1/2 plus 1/3. Right, same idea in algebra when I have x plus 5 squared. That is not the same as x squared plus 5 squared. Right, so it's the same thing when I've got trig. So it would be really nice if we could find an elegant formula for the cosine of the difference in two angles. And it turns out we can do that quite easily, and then we can extend it to sine and also to the sums of two angles. So we'll be doing that today. So this is a slide in which I'm going to set up how we're going to do our proof. We're going to start working with the unit circle, as usual in trig. So this point here is my origin, and I'm working with a unit circle, so we know the length of this side of a triangle is 1, the length of this side of the triangle is 1. I want to put some labels on for angles. We're going to call this first angle here angle B, and the angle that goes the whole way around to here is going to be angle A. Now the angle that we're interested in is not those two, it's this one in here. So that's angle A minus B. The length of the side of the triangle opposite to A minus B we're going to call L. Now that's all we need to do to start with, except that using our trig definitions, remember that we have this point on the unit circle is going to be given, the x coordinate is going to be given by the cosine of this angle here. So this is given by cos B, and the y value is given by the sine of B. Right, that goes right back to the start of our trig topic. Similarly, this point here is going to have coordinates cos of A and sine of A. Okay, now that all works. Our radius is 1, so that's why there's no r coming up in there. Right, so that lets me set up our problem, and now we're going to look at what we can do with it.
What does the fox say?
Right, so what does the cosine rule say? Well, we learned the cosine rule in Year 12, but some of you probably have forgotten it. So let's have a quick look at what it tells us. Well, here's my triangle. Right, so forget about the triangle on the previous page. Cosine rule says this. There's A, B, and C. They are my vertices, and they're also how we measure the angles. The opposite sides we label like this, A, B, and C. We did 2 rules on this in Year 12. And the cosine rule says that the cosine of angle A is equal to b squared plus c squared minus a squared divided by 2bc. Okay, so that's what the cosine rule says for all triangles. Let's now put that into the context of our triangle here. Well, if we go back to what we had on the GeoGebra slide, I'm going to extract that now, and we're just going to look at what we've got here. So the angle in the triangle, we had A minus B. The opposite side was L, and the other two sides had length of 1. Right, so the cosine rule tells us that we can find the cosine of that angle by looking at these lengths. Right, so remember it's b squared plus c squared minus a squared over 2bc. So that's for cos of A with triangle A, B, C. So ours is going to be cos of A minus B. We're looking at the other two sides, so 1 squared plus 1 squared minus L squared over 2 times 1 times 1. Just be careful to not watch the difference between the 1's and the L's. Okay, so going over that again, my basic cosine rule is here, right? And it says I can get the cosine of this angle here by taking the squares of the other two opposite sides, adding them together, subtracting off the opposite side to the angle we're interested in, then dividing by 2bc. So now we're translating that to our problem. Our angle here is A minus B. And we've got side lengths on the not opposite sides of 1 and 1, right, because we're on the unit circle. And the side that we don't know the length of is L. So it's the numerator is going to be 1 squared plus 1 squared minus L squared divided by 2. Now we can simplify that and we get 2 minus L squared over 2, which is 1 minus a half L squared. Right, so that's using the cosine rule. What do we know about cos of A minus B?
What does the fox say?
Okay, what does Pythagoras say? Well, Pythagoras is going to help us also find the value of L. Right? So working with this now, we're going to use our coordinates here. So we said that this point had coordinates cos B sine B. Right, so this point up here has got coordinates cos A sine A. And this is my angle A minus B here. But I'm not going to use this in this half of the proof. So what we're going to try and figure out is what is length L? Well, this should feel easier than the cosine rule, because you're all good at coordinate geometry. So L squared is my horizontal distance minus my vertical distance. So cos A minus cos B squared. Now I think I've just gone and done that backwards from how the book's done, so I'm just going to change that. It doesn't matter. Just a sec. So it's cos B minus cos A. So I'm working from this point back to that one. So that's my horizontal change there, and now I'm going to do my vertical change here. So it's going to be plus sine B minus sine A squared. Okay, and that's giving me, that's A squared plus B squared equals C squared. Now I just have to expand that out. So I'm going to get cos squared of B minus 2 cos A cos B plus cos squared of A plus sine squared of B minus 2 sine B sine A plus sine squared of A. Right, and onto a new slide. Right, so in here we're going to group some terms up so we can see some patterns. So cos squared of B plus, we've got a sine squared of B that comes up. And we've got minus, let's do the next bit, plus cos squared of A plus sine squared of A. So we've got all our squared terms will sit up the front. Then we've got minus 2 cos B cos A. And we've got minus 2 sine B sine A. Right, but we know that this is equal to 1, and this in the brackets is equal to 1. Right, so that's equal to 1 and that's equal to 1. So we have equals 1 plus 1 minus 2 cos B cos A minus 2 sine B sine A. So that equals 2 minus 2 cos B cos A, blah blah. But we know from the first half that we had cos of A minus B, right, using the cosine rule, we got down to this, was equal to 1 minus half L squared. Right, so the cosine of that angle in there, A minus B, was as simple as this, 1 minus a half of L squared. But now we know L squared because it's all of this thing we just got with Pythagoras. So we can put that in and expand it out, and we get 1 minus a half, 2 minus 2 cos B cos A minus 2 sine B sine A. Right, so that equals, well, 1 minus a half of 2, so that's gone. Look, the numbers have gone. How cool. Right, just watch your negatives. So we get cos B cos A. See, because we've got the negative a half there times negative 2 gives me 1. And then in here, we've got negative a half times negative 2, so I get plus sine B sine A. Right, so on to the last slide. Right, what have we found out? Well, it's pretty cool. We've found out that cosine of A minus B is equal to cos B cos A plus sine B sine A. Right, which, being alphabetical, we write as cos A cos B plus sine A sine B. So that is the first of what we call our compound angle formulae. Right, now the next thing we can do, once you've got your head around that, is we can do a couple of really easy changes to get rules for sine and rules for the cosine of the sum. So we'll do the cosine of the sum first. So cos of A plus B, how can we do that? Well, we know about the cosine of the differences. So cosine of A minus B, cosine of A plus B is equal to the cosine of A minus negative B. So all we're going to do is we're going to substitute negative B in here. So cosine of A minus negative B is equal to cos of A cos of negative B plus sine of A sine of negative B. Right, now think back to what we know about these functions. There's my cosine graph, there's my sine graph. We know cosine is an even function, so cosine of negative B is just the cosine of B. Right? We know that. It reflects in the y-axis. We've used that property lots in problem solving. So that's cos of x. Right? So cosine of any value of x is equal to the cosine of negative x. And the sine function is an odd function, so the sine of x is equal to, the sine of negative x, not enough room, sine of negative x is equal to negative sine x. So that's equal to plus negative sine A sine B. So that equals, so cos of A plus B is equal to the cos of A cos of B minus the sine of A sine B. Now I think this video is plenty long enough, so I'm going to stop there and we will do the sine ones in a separate video or maybe just in class. Thank you very much for watching. Please make sure that you've gone through this in the book. You don't have to know how to do the proof for an assessment or an exam, but I think it really gives you some insight into where Where do the formulae come from and what's going on? So I do think it's a worthwhile exercise to work through this slowly so that you understand it.